Sorry, I hit my limit on that last video. I've got a 5-minute time limit on my videos here. Um, so where I was at was I was talking about a tangent line. So if we look at any graph and then we take a point on that graph and we decide that we're going to turn that point into a line. That line that you get from doing that is what we call the tangent line. So, and the tangent is kind of a big deal because its slope of the tangent is going to be, for the purposes of calculus, what we call, it's going to be very closely tied to the derivative. I don't want to begin by defining that officially that way yet, but basically that's when you find the derivative, you are finding the slope of a tangent line at a given point. And so section 2.1 is really just giving you an introduction to slope, a review of the algebra behind it. You begin by finding average rates of change, which is giving you slopes of secant lines, and then you move into actually finding the slope of a curve at a given point, and then they ask you to find the equation of a tangent line. So let's move on into how we do that. So if we look at number 10, and so we're working with a parabola, and the point that we have is 1, -3, and we're supposed to find the slope of the curve at a given point, and they tell us to use the method that they give us in example 3. So if you look back at example 3 on page 62, they give you this method where they're defining tangent slope basically using the definition on page 61. So on these, they say use example 3, but they're using the definition that's in the box on page 61. And that definition is that the average rate of change with respect to x over the interval, over any given interval, is going to be defined as f of x sub 1 plus h minus f of x sub 1 all over h. And what we do is we basically consider, I mean, this is giving us the slope of a secant, but we're going to think of those 2 points as being the same. Like I said, whenever you find a tangent, you basically have taken 2 points that are on a secant line, and you're letting one of those points approach the other. So basically that's the method that we're going to use on these. So I think I will go ahead and finish this one out. I'll do the math, and then because it's going to get a little bit lengthy, I don't think too bad on this one, but the algebra can get a little bit lengthy, so I'll finish this out, and then I will do the explanation on it in the following video in the playlist.